This is a Neckermann Adafix 9, a pocket calculator, and I believe this one is from the 1960s, though this design is significantly older than that. Now, there are a number of things that make this thing truly fascinating. It's super thin, for one, not much bigger than a modern smartphone. It uses a stylus, and it can be used to do the four basic math operations of addition, subtraction, multiplication, and division. But all it uses are simple pieces of sliding metal. Now, the Adafix isn't all that remarkable because it's about 80 years late to the party. This calculator is a clone of the Adiator, which was designed by Louis Tranche in the 1880s. I've mentioned multiple times now the manufacturing revolution that allowed the miniaturization of parts like this. The design really didn't change all that much, and you can see in the original patents the toothed sliding metal design, though the Adafix is able to do subtraction by simply flipping it over, a feature added fairly quickly after the original introduction. Now, using an Adiator clone such as the Adafix is very simple and done with the stylus. Now, this isn't the first usage of a stylus, which actually dates all the way back to stone carvings, but it is one of the first usages for it in a computational device. Many people like to credit things like PDAs as being the first things to use the stylus, but really, this is a much older type of device than that. Now, the stylus on the Adafix, or Adiator, is used to hook into the little holes next to the digits and move the sliders. Using this, you can pull down and set a digit. Resetting is done with a handle on the top. So if I wanted to input 5, I would put the stylus into the hole next to the 5 and pull all the way down. Then a 5 is displayed in the register. Now, the Adafix here is using the convention of the time of denoting decimals, hundredths, and thousandths with different colors, and this would be helpful for currency operations mostly. So something to keep in mind is that if you want to enter in, say, 23, you would actually do it over here. Now, addition on this is incredibly simple. If we wanted to add 2 to our 23 to make it 25, we would just pull down again next to the digits near the holes. And now we have our answer 25. Where this really gets clever is when you carry a digit. If we want to add 7 to this to make it 32, we go up to the 7, but we can see that the stylus is now in this red area. Well, that's because when we pull down, it's going to lock and show us an indicator with an arrow pointing up. This means we have to pull the counter all the way up, move over into the next slot, and push the next digit of the register down. And we now have our answer of 32. This operation is not too dissimilar to pinwheel calculators of the time that would automatically rotate the next digit over when you overflow a register's counter. However, you do have to manually do it on the Adafix, and that's just a side effect of it being totally flat. You can't do a whole lot of rotating when you don't have 360 degrees of movement. So addition is very simple on the Adiator, and just for example again, let's do 73 plus 54, and there's our answer, 127. But what if you want to do subtractions? Well, the Adiator would have originally shipped with the ability to rotate it upside down and an additional set of registers on the bottom. This would allow you to pull the same numbers away to be able to change the digits. However, this Adafix has the subtraction counter on the bottom of the calculator instead, and then they're able to print the numbers upside down. You'll notice that this would be in the same position as it would on the others, but this makes it a little bit easier to mentally understand. You'll also notice when reset, the digits on the subtraction side are all red. This means that you're going to have to overflow all of them if you want to do a subtraction from 0, and these calculators really aren't designed to operate in negative values, so you're not going to want to do that. You would want to start out with a value on this side first. Actually, we're running into a slight issue here. You can underflow the digits on here, and the reset mechanism cannot reset or clear those, so you'll actually have to pull these down manually and then reset there. Anyway, let's do 100 minus 25. So we're going to pull 100 down here and flip it over for subtraction. So to subtract 25, we'll first pull 5 from the first column, and we're told to carry. Then we need to come over here, and we're immediately given a carry, but we're going to go ahead and go down to the 2 and do that. And now we see 75. Very, very simple. You just have to remember, you input the first digit on the addition side and then the actual subtraction on the subtraction side. All right, now let's step it up a notch and do some multiplication. Now, multiplication on here is really not all that much more difficult than addition. You just need to keep in mind that you need to actually do a little bit of thinking for the multiplication and multiply by digits moving over rather than just hammering away entering in the numbers. So if we want to do 12 times 12, we're going to break it down by digits. We'll multiply the first digit twice, entering in 12 in the first column twice, and then the next digit will be entering in 12 once. And now we have our answer, 144. Now, of course, if you want to do something that will be single digit and have higher values, it's going to take a while. So if we want to do 5 times 7, it's going to take a little bit of time here. Yeah, not the most practical thing, but it is usable. Now, we've covered addition, subtraction, multiplication, and that's it. And those are usually the only features that these types of calculators are advertised with. However, you can actually do division on these, but you really do have to know what you're doing. And the only reason I know what I'm doing is because I own a comptometer and have studied it quite deeply. So I'm going to do a comptometer style division on this, and I'm not going to explain it first, just because I want you to see what it takes, but know that it is actually possible. Now, I'm not even going to use the subtraction side for this because it's not necessary thanks to 9's complement. This is one of my favorite division problems. 365 days divided by 7 days, which tells us the total number of weeks in a year, approximately. And that, if you punch it into a digital calculator, is the correct answer, offset by 1 digit. All right, now that was a pretty big complicated example, and I just wanted to kind of show you how crazy you can get with division on here, but let's break it down with a more simple example of 24 divided by 6, which actually covers a lot of bases that we need to do. Now, if you want to know more about how this exactly works, I highly recommend you check out my comptometer video, because I'm not going to go over everything here, and I did in that video. But let's just go ahead and start out. So this division is done with 9's complement, which means that we're going to be adding numbers that are the 9's complement to the number that we want to subtract. So since we're doing division here, we're going to be subtracting 6, and that means we're going to be working with 3. Except for the division, we'd need to add 1 for reasons that I explained in the comptometer video, so check that out. But let's go ahead and start here, and we're going to be adding 4 to subtract 6. Now, we can't subtract 6 from 2 without underflowing, so we move on to the next digit. Now, because we have this 2 here, we actually need to add this digit the number of times it's visible in the next one. So let's go ahead and add 4 twice. And we've run into a little bit of an issue, and we had to carry, which means that this is now 3, which means we need to go 1 more time, and now we're done. We've caught this digit up to this digit. However, we still have a value in this digit's register. Now, because this value is greater than or equal to the number that we're actually trying to do the division with, we need to continue 1 more time. And after we do this carry, we see a 4 appear here, and we're 0 here, so we're all clear. And because this is 0 and it's zeros all the way across, we're now done. Now, the answer for 24 divided by 6 is actually 4, and we printed the answer 1 digit over. This is just a quirk of how this division style works. It offsets the answer by a few decimal places depending on how big your problems are, but that is actually the correct answer. You just need to do magnitude approximation. Now, that was pretty quick and easy, wasn't it? You would expect something like this to have to flip back and forth between subtraction and addition multiple times to do a division operation, but no, that's pretty easy. And there we go. We have all 4 major mathematic operations done on a calculator that fits in a pocket. That's pretty cool, isn't it? Now, you might wonder, well, can you do square roots or, other complicated mathematic operations? And while technically yes, you never would have on that because slide rules exist, and slide rules existed before this did. So really, if you wanted to continue on and do more complex mathematic operations, you would have used one of these. And while this video is definitely not going to go into the operation of a slide rule, I bet that this is a combination that would have been used for quite some time. And I just find that somewhat amusing. Well, I hope you enjoyed this quick video taking a look at the Addiator clone Adafix here that I have. Thank you to Tomatolicious for sending this. I've been meaning to get one of these for quite some time, and it is every bit as interesting as I had hoped it would be. These are frequently called arithmometers, and while the original patent for Tranche's version was called an arithmograph, I believe, at no point should these have ever been called arithmometers because that's something completely different. So call it an Addiator. That's really what it is. Anyway, hope you enjoyed this look, and if you want to see more calculator stuff, I recommend you subscribe because I'm fascinated by these things. If you want to support the channel, I am on Patreon, but for now, that's it, and I'll see you next time.